An elasticity of substitution is a measure of the degree of substitutability that is built into an indifference curve or an indifference map. Its formal formula is that it's the percentage change in the ratio of x2 over x1 divided by the percentage change in the marginal rate of substitution. To give some intuition to what this formula means, we'll develop some graphs here to show what it is that we mean by the percentage change in the ratio of x2 over x1 and what we mean by the percentage change in the marginal rate of substitution. We begin with two indifference curves drawn from two different indifference maps representing two different tastes. In panel A, we recognize this blue indifference curve as one that looks relatively close to perfect substitutes and therefore must have a high degree of substitutability built into it. In panel B, we recognize the magenta indifference curve as deviating a bit more from the case of perfect substitutes and thus incorporating a lower degree of substitutability than the blue indifference curve in panel A. Suppose then that we want to estimate the elasticity of substitution along the blue indifference curve between bundles A and B. At bundle A, we have 10 units of x2 and 2 units of x1, giving us a ratio of x2 over x1 equal to 10 over 2, or just 5. At bundle B, on the other hand, we have 4 units of x2 and 8 units of x1, giving us a ratio of x2 over x1 equal to 4 over 8, or just 1/2. The change in the ratio of x2 over x1 between A and B is therefore 5 minus 1/2, or 4.5. We can then do the same exercise for bundles A and B along the magenta indifference curve in panel B. Bundle A is the same as the bundle A on the blue indifference curve, 10 units of x2 and 2 units of x1, giving us a ratio of x2 over x1 that's equal to 10 over 2, or just 5. At bundle B, on the other hand, we have 8 units of x2 and 4 units of x1, giving us a ratio of x2 over x1 that's equal to 8 over 4, or just 2. The change in the ratio of x2 over x1 as we go from A to B along the magenta indifference curve is therefore 5 minus 2, or just 3. In panel A of the graph, we've chosen bundles A and B such that the marginal rate of substitution changes from minus 2 at bundle A to minus 1 at bundle B. The change in the marginal rate of substitution as we move from A to B is therefore 1. Bundles A and B along the magenta indifference curve were chosen in exactly the same way, with the marginal rate of substitution at bundle A equal to minus 2 and the marginal rate of substitution at bundle B equal to minus 1. Bundles A and B are closer together along the magenta indifference curve than they are along the blue indifference curve because of the greater substitutability that's built into the blue indifference curve, which makes it flatter. Now let's look at the different components of the elasticity formula. The denominator of the elasticity formula is the percentage change in the marginal rate of substitution. In both panel A and panel B, we started with a marginal rate of substitution of minus 2 and ended with a marginal rate of substitution of minus 1. Thus the percentage change in the marginal rate of substitution as we move from A to B along the blue indifference curve is exactly the same as it is as we move from A to B along the magenta indifference curve. In other words, our elasticity of substitution formula has the same denominator for panel A as it does in panel B. The numerator of the elasticity formula is the percentage change in x2 over x1. In panels A and B, we always start at bundle A, which is identical across the two bundles, and therefore x2 over x1 is initially identical. But the change in x2 over x1 is larger along the blue indifference curve as we move to bundle B than it is along the magenta indifference curve. Thus the percentage change in x2 over x1 is larger in the blue case than it is in the magenta case. Since the denominator is the same for both cases, we get an elasticity of substitution that is larger for the blue indifference curve than it is for the magenta indifference curve, indicating a higher degree of substitutability for the blue indifference curve. Notice what it is that we're really saying when we're saying that the percentage change in the ratio of x2 over x1 is large or small. If it's large, it means that we've moved a long distance along an indifference curve to get from one bundle to the next. If it's small, it means that we've moved a small distance. In panel A, the change in the ratio of x2 over x1 is large because there's a great distance between A and B, precisely because of the high degree of substitutability in the indifference curve. In panel B, that distance is smaller, implying that the change in x2 over x1 is smaller for the same change in the marginal rate of substitution. Thus, when the elasticity of substitution is high, it means that we move far along an indifference curve for a given change in the marginal rate of substitution, and when it is low, it means we don't have to move very far along an indifference curve for the same change in the marginal rate of substitution.